Hey guys, Al here, Vitalized Seed. I wanted to talk mycorrhizal fungi. So this is about the best picture I could find that I thought did a good visual or showed a good visual representation of kind of what mycorrhizal fungi is and does. And it's not perfect. You might be able to find something else out there better that works for you and the way you learn. But I thought this would be good for this video. So as you can see here in this case, we have a tree seedling. The soil, let's just say that topsoil there before the roots really start let's just assume that's about 2 to 3 inches. And then you kind of have your root mass, which is everything that's not white. So that's just if you did no fungal networks, no mycelium, etc., you would just have those roots in the soil. Now you can imagine in a cover cropping situation or a garden or a food plot or a farm field, etc., you have a higher density of plants and roots and different levels and depths of the plants and roots growing down into the soil. But if you lend your system or focus on your system being much more focused on bacterial and fungal dominated, so over time through not tilling, that's why forests are primarily fungal dominated systems versus bacterial, you have more mycorrhizal fungi, which allows for more mycelium to be into the roots and extend your root mass by volume. So here you see, if it was just the brown behind my head, that would be your roots. All of the white is showing mycelium or that mycorrhizal fungi connection, which is creating glomalin, which is biotic glue, which is allowing for better biological soil aggregation, which is going to help from water infiltration, microbial flow, being able to build up organic matter over time, etc. So we're going to have the benefits of all of those. And then, of course, mycorrhizal fungi is going to help to solubilize a lot of the nutrients that tend to be bound up in the soil. So, for example, we'll talk about phosphorus. If you only had your roots here, let's say buckwheat. Buckwheat's known to have a root exudate that helps with phosphorus availability. But if the exudates are only coming out here at the bottom of one of these brown tips, we're missing. What about all the phosphorus that might be tied up around the circumference of those particular roots? So long story short is, as we focus on soil health and we increase our fungal populations in the soil, we're able to take much better advantage or full advantage of the nutrients that are tied up, because we're able to solubilize them through biological activities of root exudation and fungal solubility, as well as bacterial solubility of those particular nutrients that are going to then bring those nutrients back to the plant. As that plant is terminated or dies, those nutrients are then in that top 3 inches. Previously, maybe they were way down here at some of the tips of the white nutrients, and we can continue to cycle that through a natural process of maximizing our biological communications within the soil profile. So think again, this is one tree, this is one example of a root mass. Imagine if this was a highly diverse mix up here with all varying root structures and the mycelium going in and communicating with all of those different root structures and having that mass spread out across. You can see how you're increasing your overall root matter and root mass through the mycelium so that we can get more nutrients out of your soil profile. Get outside, guys. Enjoy the outdoors. VitalizeSeed.com.